Working with Data, Part 1, Introduction. Variables are factors that can vary from one person to another. Examples include gender, age, self-esteem, reading ability, on-task behavior, perception of support, and type of treatment received. Measures are the instruments or tools we use to assess each participant's amount, frequency, level, or standing on a behavior. Examples include a questionnaire survey, test, observational checklist, and interview questions. Note that measures can be quantitative, involving number data, or qualitative, involving verbal, text, or visual data. Data are the specific scores, responses, observations, etc. that represent each participant's measurement. Examples include IQ score, extent of agreement with a statement, number of sessions attended, and anxiety measure total score. When we report results of a study, we use data to say something meaningful about the variables we have measured. For example, a score of 100, data, on an IQ test, measure, suggests that a person has average intelligence, variable. Here are some examples of variables, measures, and data. Test anxiety could be measured with a test anxiety scale, which would yield an anxiety score with, for example, possible scores ranging from 0 to 50. This would be a quantitative variable. Reading ability could be measured with the developmental reading assessment, which yields a reading level from 1 to 80. This is also a quantitative variable. Satisfaction with treatment could be measured with the Likert scale item, which yields a satisfaction score ranging from 0, representing a response of strongly disagree, to 4, representing strongly agree. This is a quantitative variable as well. Perception of colleagues could be measured with an interview question, which would yield a narrative response such as, I think, such and such. This is a qualitative variable that would need to be coded to indicate the nature of the response received. Finally, on-task behavior could be measured with an observation checklist, which could yield both the frequency of on versus off-task behaviors, as well as a description of such behaviors. In this case, the variable would have both a quantitative part, that is, the frequency, and a qualitative part, that is, the description. In preparing quantitative data for statistical analysis, there are 3 steps. First, you must score the test, add up the number of behaviors observed in an observational protocol, or perform other preliminary data checking. If you have any nominal variables, such as gender or race, you might want to code those variables numerically so that each participant has numbers that represent his or her gender and ethnicity. Next, you should check your scoring for consistency and accuracy. If you have a very large data set, it is acceptable to double-check just 10 to 25% of the data set, but you should always eyeball the entire data set to make sure that there are no unusual values. For example, if the maximum score on a test is 100, you should not see any values above 100 for this variable. The third step involves tabulating data, or organizing the data systematically, such as organizing the data by participant. For instance, if you have more than one measure, you might want to group the measures by participant, rather than putting all of the scores on the first measure together and all of the scores on the second measure together. This will facilitate entering data into a spreadsheet, as spreadsheets are generally organized with participants as the rows and variables, or even items within a measure, as the columns. Here is an example of a data set with a few rows of a spreadsheet. In this data set, ID represents the participant number. Condition represents the experimental condition. In this case, 1 means treatment group and 2 means control group. For gender, female is coded 1 and male is coded 2. Finally, support and satisfaction are items that were measured with a Likert scale, which has response options ranging from strongly agree to strongly disagree, with neutral or neither disagree nor agree in the middle. Additional rows would be added for additional participants, just as additional columns could be added for additional variables. Note that in this small data set of 3 people, there were 2 people in the treatment group who received some sort of intervention, and 1 person in the control group who received standard care or regular instruction, as shown in the condition column. In the treatment group, there was one male participant and one female participant, as shown in the gender column. The first participant, row 001, strongly agreed that he felt supported during the study and agreed that he felt satisfied with the treatment he had received. The second participant, row 002, indicated that he was neutral in terms of receiving support, but disagreed that he was satisfied with the care he had received. The third participant, row 003, responded that she agreed that she felt supported and strongly agreed that she was satisfied with the treatment. Now you are ready to analyze the data. We use data to answer questions. By analyzing the data, we can take a lot of information and reduce it to a few key points. Although it is possible to focus on individual participants when analyzing data, we are usually looking at an entire group of participants. Different methods are used for analyzing quantitative and qualitative data. In quantitative studies, we typically use statistics to analyze data. In qualitative studies, we typically use coding to analyze the data. Quantitative data analysis is designed to answer one or more questions. The most basic question is, how many people responded in a certain way? For example, we want to know whether participants were generally satisfied with the intervention, as measured with a single Likert scale question. Overall, I was satisfied with the treatment. We can calculate frequencies for each response option: strongly agree, agree, neutral, disagree, or strongly disagree. We can also express these frequencies as percentages of the total number of participants responding. The first type of statistic is frequency. The frequency refers to the number of people with a specific status on the measure or item of interest. For example, we could say that there are 50 boys and 50 girls in the sample. As another example, we might report the number of people who generally agreed with a statement, as reflected in answers of strongly agree or agree, and the number who generally did not agree, as reflected in answers of neutral, disagree, or strongly disagree. Note that percentage is related to frequency, as it is the frequency of some response or category divided by the total sample size or group size. For example, girls made up 50% of the class, or among new teachers, only 40% strongly agreed or agreed. Another question we might ask is, were participants' scores similar to or different from each other? In this case, we want to know whether participants' test scores were close together or whether there was a lot of variability in scores. We can look at the spread of scores, how many scores were low, medium, and high. We can also look at extreme scores, unusually low or unusually high, called outliers. Graphing is a great way to examine this question. It will show us whether scores are close together or far apart, and whether there are any scores that are highly discrepant from the rest of the scores. This graph illustrates the distribution of scores for 100 participants. Possible scores range from 0 to 100. It appears that only one participant scored 50, 4 scored 70, 40 participants scored 80, 35 scored 90, and 20 participants scored 100. The spread of scores is pretty large, as participants had scores ranging from 50 to 100. However, the score of 50 was probably an outlier. Only one participant had this score, and the score was quite discrepant from the rest of the scores. Thus, we would have to decide whether to include that participant in the additional analyses, which could make the results less accurate, or whether to omit that person from the data set, which could overlook important information about the outlier's response. An alternative is to examine the data set both ways, with and without the outlier data point, and to examine the outlier participants' data separately. When working with small groups of participants, there is often quite a lot of spread or variability in the data. This makes it harder to characterize the typical or average response or score. In that case, we might want to look at each participant separately. In this graph, there were 5 participants, each of whom had a different score: 10, 30, 65, 80, and 90. Given how different the scores are, it is probably not useful to try to characterize the overall group performance. Instead, we might want to group participants into categories and just report frequencies, such as 2 out of 5 participants had a score below 65, while 3 out of 5 participants had a score of 65 or above. We are often interested in how a group performed as a whole. One way of capturing this is calculating the average, or mean score of the group. For example, what is the average self-esteem score of girls in 6th grade? To determine this, we would sum all of the participants' scores and then divide by the number of participants. The mean is the most commonly used statistic. To calculate the mean, all the scores are summed and then divided by the number of participants. For example, if we have 4 participants who scored 100, 95, 80, and 70 on a measure of self-esteem, we would sum these scores to get 345. Then we divide this sum by the number of participants, in this case 4, and the result is the mean, 86.25. Note that we usually report numbers to only 2 decimal places. Note that the mean is not perfect. It does not always represent the most common score. In this example, no one actually scored 86.25, though 2 participants, those scoring 80 and 95, were close. However, unless there are major outliers, that is, unusually high or low scores that differ substantially from the rest of the group scores, the mean is an adequate representation of the group score. Although the mean represents the average score, we also need a summary of the variability in scores. The most common measure of variability is the standard deviation. Note that standard deviation is abbreviated SD. To summarize, our research question will determine our data analysis plan. Frequencies and percentages are useful for summarizing the number of participants who responded or scored a certain way. Graphing is useful for determining whether participant scores are close together or spread apart, and whether there are any unusually high or low scores. And the mean is usually an adequate representation of the group score.